Welcome to Chemistry with Dr. Z. I'm Dr. Z, and in this video, I'm going to talk to you about how to assign the configuration of your chiral center. So we talked about enantiomers and chirality, and we said that the two enantiomers are two different compounds, and because they are two different compounds, they need to be given a different name. And here, the EWAC name itself will stay the same, but we just add a prefix to that name as R or S just to assign the configuration or to decide which enantiomer is this particular molecule. So what does R and S mean? How can we assign the R and S configuration of the molecule? We usually give priority to the four different substituents that are attached to our chiral center, and then we arrange these, give them priority and arrange them as 1, 2, 3, 4, following the CIP rule. So CIP rule is the Kahn-Ingold Prelog rule, which we call it CIP rule. So before we start assigning the configuration of our chiral center as R or S, we need first to familiarize ourselves with the rule, the CIP rule. So to establish the priority between the different substituents attached to our chiral center, we follow this rule. So how can we give priority to one group over the other? So normally when we assign the priority, we start looking at the atoms that are directly attached to the chiral center, and then we look at the different atoms attached and we give them priority. We never look at the whole substituent, we look at them atom by atom. So the first thing to assign the priority is to order them by atomic number. So if you have substituents like chlorofluoro, oxygen, for example, then chlorine or chloride substituent has higher atomic number, so it's going to take priority over fluoride, which is going to take priority over oxygen, which is going to take priority over nitrogen, and so on. So you just look at the atomic number. We don't look at the atomic mass. We all put them in order of their atomic number. So what if we have two different isotopes? Are they considered as two different substituents or are they the same? If you have two isotopes of the same atom, like hydrogen and deuterium, they are considered as two different substituents, and then we will give them priority based on their atomic mass. So because both isotopes will have the same atomic number. So we start off with atomic number. If the atomic number is the same because they are two different isotopes of the same atom, then we follow this by the atomic mass. And then the priority, we need to look at the atoms one by one. All right, so we don't look at the whole group. So if we have the same priority for the first atom, we start looking at the first point of difference. So let's have a look to understand what do we mean by this. So if you have a substituent like ethyl and another one like this one, which is isopropyl, which one will take the priority? So the first point of attachment here, so the chiral center will be here for both. All right, so the first atom here is carbon and here is carbon as well, so they have the same atomic number. Okay, so we need to look for the following atoms. So the first point of difference, this carbon, okay, the first carbon here is attached to two hydrogens and one carbon, but this carbon here is attached to two carbons and hydrogen. So the first point of difference will be this carbon atom, because here it's only one carbon and two hydrogen, but here there are two carbons. So this one will take priority, and this is the first point of difference. So let's have a look at these two. So this is CH2, CH2SH, CH2, CH2SCH3. So CH2 exactly the same, and then CH2, the second one exactly the same, and and then the S exactly the same, but here the sulfur is attached to hydrogen, but here the sulfur is attached to the carbon. So this is the first point of difference. So this one will take the priority. The third example here, you have CH2, CH2OH, or this one, the isopropyl, CH, CH3, CH3. You might think that this one should take priority because it has an oxygen. But as I said before, we don't look at the group as a whole, we look at the first point of difference. So let's find the first point of difference. Here, this is again the stereogenic center, and the first atom here is carbon, and here is carbon. But this carbon is attached to two hydrogens and one carbon. This carbon, on the other hand, is attached to two carbons. So this one will take priority over that one because there is an extra carbon here in comparison to the hydrogen. So this one will take priority even though there is an oxygen, because this is the first point of difference. What about these two here? So again, the stereogenic center is here. So CH2, here it's CH, and then there is a deuterium and a carbon. This is two hydrogens and a carbon. And this second carbon is attached to three bromides. But again, let's look at the first point of difference. The first point of difference will be this deuterium, because on this first carbon here, you have two hydrogens and a carbon, but this one has a hydrogen, a deuterium, and a carbon. The carbon and hydrogen are exactly the same here, but the third atom here is hydrogen and here is deuterium, and we said that we're gonna, if the atomic number is the same, then we're gonna give priority to the one with the highest atomic mass, which is deuterium. So what about multiple bonds? If we have a double or triple bond, how can we deal with this? How can we compare it? So if you have a double or triple bond, then you need to consider this double bond as if they are single bonds. Of course, they are not single bonds, but for the sake of the rule, for the sake of how you can actually make it easier to give priority to the different groups, then you have to split it. So if you have two, a double bond here, then this first carbon here, we will consider this as if it's connected to another carbon here. So this extra carbon we drew is actually this carbon it's attached to by a double bond. Also, this second carbon here also will have an extra carbon, which is the first one here, carbon number one here. So we just simply split it and as if each one is attached to an extra carbon. The same will apply if you have a carbon with a double bond and an oxygen, a carbonyl group. Then the carbon we will consider as if the carbon is attached to an extra oxygen. So it's already attached to this oxygen, but it's also, we consider it as if it's attached to another oxygen, and the oxygen will be attached to an extra carbon. We will apply the same rule if we have triple bonds. So this carbon number one here, we will consider it as if it has two extra carbons attached to it because of the triple bond. So each bond we will split it as if it's a single bond with an extra atom. And the second carbon as well here is also attached to two extra carbons. Same applies to carbon with triple bond nitrogen. So the carbon as if it has two extra nitrogens, and the nitrogen as if it has two extra carbon. So this is how we give priorities to our groups. So now we need to label our stereogenic center with R and S. So let's have first some examples of assigning the priorities to our stereogenic center. So let's start with this compound first. So this compound has a stereogenic center, this carbon in the center, with four different groups. One is bromide, the other one is chloride, the third one is CH2I, and the fourth one is hydrogen. So you always need to look at the atoms which are directly attached to your stereogenic center. So which one will have the highest priority? Bromide will have highest priority because it has the highest atomic mass in comparison to the chloride and the carbon. We don't look at the iodides here because this is not the first point of difference. The first point of difference is the first atom attached. So bromide will have the highest priority. It has the highest atomic number, so we will give it priority 1. And then chloride again has higher priority than chloride. It has higher atomic mass than carbon, chloride than carbon, and of course more than hydrogen. Hydrogen will always take the lowest priority. If you have hydrogen, it will always be number 4. So chloride will be number 2, and then the CH2I will be 3, and then the hydrogen 4. So now we assign the priorities. So what about a compound like this one? Don't panic if you see a big compound like this one. All what you need to do is to find your stereogenic center, and this is our stereogenic center because this is the only carbon that has 4 different substituents. Now we need to assign priority. First point of difference, right? So the first carbon, the first atom attached to the stereogenic center is carbon, but this one is carbon attached to 2 carbons, 2 methyl groups and a hydrogen. This one 2 hydrogens and a carbon. This one 2 hydrogens and a carbon. This one 3 hydrogens. So this is going to take the highest priority. And then we look at these two. So of course CH3 will be the lowest because it doesn't have a second carbon attached to it, just 3 hydrogens. So now we know which one is going to be the first and which one is going to be the last. So we have these two. Why this one took priority over this one? So let's have a look and try to find where is the first point of difference. So CH2, CH2, then CH2, CH2, and then CH2, and this is CH3. So this is CH2 attached to another carbon, but this is CH3. So this is the first point of difference, this carbon here. So this one will take priority over the third one. Moving on to the third compound, so we have the stereogenic center attached to 4 different groups. Let's have a look. The first atom here is oxygen. He's here is carbon. Here's carbon and hydrogen. So this is going to take the first priority. And then we all said that hydrogen will always will always have the lowest priority. So hydrogen is the fourth one. So which one will be the second? This one is carbon attached to an oxygen and 2 hydrogens. But this one is a carbon attached to an oxygen with a double bond and another oxygen. So as if it's a carbon attached to 3 different oxygens. So this is going to be the first point of difference because this one only have one only it only has 1 oxygen and 2 hydrogens, but this one has 3 oxygens, so this takes priority. So this is 2 and this is 3. So now we assign the priority of the different groups. We start looking at our molecule, and when we look at our molecule, we ignore the group with the lowest priority. We always ignore the group number 4. We only look at 1, 2, and 3. And when we look at our molecule, we need to see how they are arranged from 1 to 2 to 3. So let's have a look at this molecule, for example. So this molecule has 4 substituents given priority 1, 2, 3, and 4. And if you look at the molecule here, so they are going to be arranged from 1 to 2 to 3. We will ignore number 4 completely. So from 1 to 2 to 3, this goes clockwise. If the arrangement goes clockwise from A to B to C, or from 1 to 2 to 3, then we give it the prefix R. So the configuration here is going to be R. Let's have a look at this one. So this is 1, 2, and 3. And the arrangement now goes anti-clockwise or counterclockwise from 1 to 2 to 3. Again, we ignore the fourth one. So this is going to be given as configuration. So the procedure for assigning the RNS configuration, first in order to label our enantiomer as R or S, the first thing we need to assign the priority from 1 to 4. like this molecule here. This is 2-butanol, and into butanol, OH, this group is going to have the highest priority. Then the ethyl is number 2, methyl number 3, and hydrogen number 4. And as we can see, this is the decreasing priority. So this is the highest, and this is the hydrogen with the lowest. Then we will start to look at our molecule and decide whether or not these are arranged clockwise or anti-clockwise. So let's have a look at these two enantiomers of 2-butanol to decide the um, configuration. Remember that these two here are mirror image to each other. So you can see these A and B are mirror image to each other. So they are the two different enantiomers of the same molecule. One of them is R and the other one is S, but which is which? So if you look at compound 1, we said that OH is 1, and this is 2, and this is 3. Arrangement from 1 to 2 to 3. It goes clockwise, so it's an R. This one, this is OH is 1, the ethyl group is 2, and the methyl is 3, hydrogen is 4. We see from 1 to 2 to 3, it goes anti-clockwise, so it's an S. Always remember that the two enantiomers, one of them is going to be R and one of them is going to be an S configuration. All right, so if you look at this molecule, it's very important here that you see three different types of bonds. The three different types is the normal line bond here for the OH and the ethyl group. And there is the solid wedge one. This is the one that's attached to the that gives you the bond between the stereogenic center and the methyl. And there is this dashed bond with the hydrogen. Remember that tetrahedral carbons are have two planes, and not all the atoms or not all the bonds in the same plane. And when you look at the molecule, there will always be a group that is goes beyond the level or the plane of the page, because there are two different planes for the molecule. So um, in order to decide which group is at the back or at the back of the paper, when you try to draw it, because it's 3D, when you try to draw it on a paper, then the one which is at the back will be drawn with this wedged a line, or with the dashed line. That means the hydrogen here is at the back, the methyl group, because it's this solid wedge, that means it's at the front, and the OH and the ethyl are on the plane of the page or of the paper when you draw your structure. When you assign the priority, when you assign the configuration after giving priorities, you cannot start assigning the configuration as R or S unless the group with the lowest priority is at the back. So you have always to find that, or to draw your the group with the lowest priority, or the substituent with the lowest priority, to be at the back, to be with the wedged line. So what if the group that has a bond which is wedged, which means this is the one at the back, is not the one with the lowest priority? How are we going to assign the configuration? So let's have some examples here. So if we have a structure like this one, right? So let's first assign priority and try to assign the configuration. So a compound like this one, this is the stereogenic center here, okay? And we have four groups. We have NH2, hydrogen, we have methyl, and we have ethyl here. Remember that hydrogen will always be the lowest priority. So hydrogen is number 4. Hydrogen is drawn here with a dashed line, which means it's at the back. So we don't have any issues assigning the configuration here. Okay, let's assign the priority of the different groups. So NH2 will take the highest priority because nitrogen will have priority over the carbons on these two other groups. And then the ethyl will be group number 2, and then the methyl will be 3. So let's see how it goes from 1 to 2 to 3. So it goes clockwise. So this is going to be an R configuration. All right. So what about this molecule here at the bottom? This molecule is exactly the same like the one at the top, But now the one substituent that has the wedged line, the dashed line, um, is the NH2, which is not the one with the lowest priority because hydrogen is the one with the lowest priority. So hydrogen is 4, nitrogen is 1, ethyl is 2, and the methyl is 3. So how can we assign the configuration? We cannot follow the same rule. We need to do some changes. We need to flip this molecule. We need to make the hydrogen at the back. How can we do this? We can use one of two methods, and you are free to use any method you feel more comfortable using. So the first way is to redraw your molecule. And when you redraw your molecule, you start off by replacing the position of these two groups, making the hydrogen at these two groups, making the hydrogen at the back. So you swap the position of the hydrogen and the one that is at the back to make the hydrogen at the back. But we keep them on paper on the same place, but we just replace the type of bond. So we're gonna make the hydrogen at the back like this, and we make the amino group NH2 as if it's at the front. So what about these two groups? In this case, in order to put them in the right position, you need to swap their position as if you have rotated your molecule 180 degrees. So now the ethyl group will be to the left here and the methyl will be to the right. Now you can start assigning the configuration of your molecule. So this is the first way. So NH2 is 1, ethyl is 2, methyl is 3, hydrogen is 4. When you look at the how you can assign the configuration, how they go from 1 to 2 to 3, you can find it's anti-clockwise or counterclockwise, so it's an S configuration. So this is the way how you assign, one of the ways how to assign configuration if the lowest priority group is not at the back. There is a different method as well, which is so easy. You can simply apply it without redrawing your structure. And this is how we do it. So you just simply look at your molecule like this one. You assign the priority as usual, 1, 2, 3. Remember that the group that is at the back with this dashed line is not the lowest priority group. So I can just deal with it as if it's as if the one with the lowest group at the back, and then I'm going to look how the different groups are arranged. So from 1 to 2 to 3, it's clockwise. Right? If it's clockwise, I'm not going to give it the R configuration. I'm straight away going to give it the opposite configuration, which is S configuration. So if the arrangement is clockwise and the group which is has the lowest priority is not at the back, then I'm going to assign the opposite configuration of my stereogenic center. So if it's an S, I'm going to give it an R. So, and if it's an R, I'm going to give it an S because here the arrangement is clockwise. It should be an R, but because hydrogen, which is the lowest priority, is not at the back, then I'm going to give it the opposite configuration, which is an S. This is a very simple way of assigning configuration if the lowest group is not at the back. Let's have another example. So we have this molecule. Let's give priorities to the different groups. So we have the OH here is going to be has high is going to have the highest priority. So this is number 1, and hydrogen, of course, going to be number 4. Then we have these two groups. Which one will take priority? Let's look at the first point of difference. This is a carbonyl group, and this is a carbonyl group. So exactly the same carbon with double bond oxygen, carbon with double bond oxygen, but then this carbon is attached to an oxygen and this one is attached to a hydrogen. So this is the first point of difference here. So this oxygen in comparison to the hydrogen, so this is going to take priority over this one. So this is 2 and this is 3. Of course, OH took the highest priority because oxygen, in comparison with the carbons here, these two are carbons, will have higher priority because oxygen has higher atomic mass. Now the OH is at the back, is not hydrogen. Hydrogen here is not at the back. So let's follow the rule we just talked about before. So the arrangement from 1 to 2 to 3, orientation is going from here to there like this. So it's clockwise. And because it's clockwise, we will normally say clockwise is an R configuration, but because the hydrogen is not at the back, it's going to be an S configuration, not an R configuration. So we give it the opposite configuration straight away. Okay, so what if I want to draw the enantiomer of my structure? There are two ways to do this. The first way is simply to draw the mirror image of that structure. So I'm going to draw the mirror image. So here I'm going to have this carbon, the different groups, and then I need to have the OH here and the hydrogen this side. So these two are the mirror image. So I simply draw the mirror image. What if I have a very big molecule and instead of drawing the structure and try to draw the mirror image, I can simply do a very simple thing to swap the configuration. And this is by swapping these two groups, the one with the dotted or the dashed wedge or with the dashed line, and the one next to it, or the one with the lowest priority. So in this case, I'm going to place the one which is with the dashed line, the one which is at the back with the lowest priority. So in this case here, okay, so I can simply swap these and keep the molecule exactly the same. So OH like this, hydrogen at the back, and then keep the molecule exactly the same. And we look at this molecule, you're gonna find that this one was an S configuration, and this one, 1, 2, 3, is an R configuration. So it's the enantiomer of that molecule, because we said that the enantiomers, one of them is an S, one of them is an R. What if the hydrogen is, or what if the one with the lowest priority is the one with the dashed line? Then I simply swap it with any other group. So if I want to draw the enantiomer of this molecule, I can swap the hydrogen with any of these three different groups. It doesn't have to be with the OH, with any of these three different groups, because when I do this again and keep everything in place, when I do this, the configuration will always be the opposite configuration, will always be the S configuration. So I can simply draw the enantiomer of this molecule here, because the hydrogen now has the lowest priority and it's at the back, by swapping the position of the hydrogen with any other group. So let's swap it with the group number 3 that has priority number 3. So I'm going to keep the OH in its place. Okay, add the one going forward. The hydrogen will be a normal solid line, and then this group is going to be at the back, and then this one is going to be like this in its position. Okay, so remember that as long as the group with the lowest priority is not the one at the back, we are going to convert, or we are going to flip the configuration. So this one is still going to be an S configuration. So this one is exactly the same like this one. They both are S configuration. They are both the same the same compound. So this is how to draw the R and S configuration of a compound, or if you have a chiral compound, and then how to draw the enantiomer of that particular compound, either by drawing the mirror image of it, simply by looking at it and drawing the mirror image of it, or simply by swapping the one at the back with a different group, either with the one with the lowest group, or swap the one with the lowest group with a different one.